Welcome back to Vuln Vibes. In this deep dive, we are going straight into the heart of a major zero-day finding impacting enterprise security. We're talking about the recently disclosed pre-authentication remote code execution vulnerability, CVE 2025-61757, found deep inside Oracle Identity Manager, or OIM.
And this is a really critical one for anyone in the identity management space. I mean, OIM is not just some random piece of software.
No, not at all.
It's the gatekeepers. It's safeguarding core identities for, hundreds of Fortune 500 companies, massive government entities. If you pop OIM, you basically own the entire digital estate.
And the background here is it's a huge warning sign. I mean, the context for this discovery is that catastrophic Oracle Cloud login breach from earlier this year.
The big one.
The one that compromised 6 million records across 140,000 tenants.
Yeah.
It was all because Oracle itself was running just laughably outdated software.
Yeah, vulnerable to that old 2021 flaw, CVE 2025-61757. It was like a textbook case of failing to patch your own stuff, just pure technical debt.
And that failure really sets the stage perfectly for what we're talking about today.
Yeah.
Because this new vulnerability, CVE 2025-61757, is a brand new pre-auth RCE.
Right.
And it would have been just as effective, maybe even easier, to use against that same login.us2.oraclecloud.com host. It just proves OIM is this massive high-value target.
Exactly. And our mission today is really to analyze that full attack chain. We're going to look at the symmetry of this exploit.
Symmetry, I like.
Yeah, because you have this surprisingly trivial filter bypass, something that feels like it's straight out of 2005. And then it's combined with this incredibly sophisticated, almost CTF-level technique to get RCE.
Yeah.
It's a synthesis that every security pro really needs to understand.
Okay, so let's start at the beginning. Target acquisition. What exactly were the researchers looking at when they started their recon?
Right, so they were focused on Oracle Identity Governance Suite 12c, specifically version 12.2.1.4.0. And when you dive into a big Oracle app like this, you're not dealing with some neat little microservice. It is a genuine monolithic beast.
Right.
I mean, a huge application packaged as a bunch of Dart files, and inside those are dozens of nested .war files. It's just a distributed Java spaghetti mess.
It sounds less like AppSec research and more like digital archaeology. So how do you even find the starting point in that kind of code base?
Well, they started with what they could see. They knew certain paths had to exist, like identity face swap pages main.jspx, just from using the admin UI.
So they use that as an anchor.
Exactly. They use that known path to trace the file back through all the archives.
And they find it inside oracle-hedm-yshell.jar, which is itself nested inside the main om.ear. So that kind of narrows the focus.
Right. And once they had that scope, they immediately pivoted to the administrative APIs. They just started digging through web.xml files and all the different .war modules, looking for context roots that sounded, dangerous.
Things related to management or configuration?
Precisely. Things that sounded like they handled back-end admin tasks. They found some promising ones like IAM Governance Admin Service APIV 1 and the crucial one, IAM Governance Application Management.
High privilege operations. That makes them the perfect target if you can just get past the authentication.
Mm-hmm.
So that brings us to the core problem. They target an endpoint, let's say find templates, they send a request, and even though the endpoint itself doesn't seem to need a session, boom, 401 error. What does that scream to a researcher?
It's a huge red flag for a centralized security model. It's such a classic and kind of error-prone pattern in these older enterprise Java apps.
Instead of modern root-level security?
Yeah, exactly. The whole application relies on a single catch-all security filter defined in web.xml. In this case, it was the security filter.
And whenever you see one of those custom filters trying to whitelist unauthenticated paths with like string comparisons or brittle rejects, you just know that security boundary is soft.
Oh, absolutely. You were fighting the framework. So the goal becomes, let's just analyze the filters, do filter method, and find the bypass.
Yeah.
And they found two. The first one was almost comically simple.
The query string bypass.
Yeah.
Tell us about that.
The filter literally just checks if the query string, after being trimmed, equals the string WSDL, case insensitive. If it does, the filter just stops and passes the request right on through.
So you're telling me I can just slap WSDL onto any REST API endpoint and the main security gate just swings wide open?
That's it. An immediate, high-impact bypass.
So why didn't they just stop there? I mean, that's a finding right there.
Because it's a bit noisy, And sometimes appending a weird query string like that can mess with how the actual endpoint expects to get its parameters. They wanted something cleaner, something that looked more like a normal request.
Which brings us to bypass number 2.
Right. The second condition, this one used a regex that required the URI path to end in .waddle.
Okay, but just pending .waddle to a URL would normally just 404, because that path doesn't actually exist, right? The server can't map it.
Correct. And this is where that deep knowledge of the servlet API really pays off. We're talking about matrix parameters.
The gift that keeps on giving in Java exploitation.
It really is. See, Java's getRequestURI function is designed to handle these things called path parameters or matrix parameters. They start with a semicolon.
Okay, pause for a second. I want to make sure everyone gets why this is so slick. Why does the security filter see the .waddle it's looking for, but the REST endpoint itself doesn't break?
It's all about dual interpretation. The security filter calls getRequestURI, and that function returns the entire path, including the matrix parameter. So it sees templates.waddle.
And that matches the filter's regex because it ends with .waddle.
Exactly. But then when the request goes downstream to the actual REST framework, its routing logic is smarter. It often ignores or just strips out matrix parameters, so it only sees the clean path templates.
Wow, so the filter's fooled, it lets the request through, and the endpoint gets the path it was expecting and executes without a 404. That is a fundamental flaw in path canonicalization.
It's a beautiful bypass. The final URL was just elegant. EM governance application management templates.waddle. And with that, they had pre-auth access to all those dangerous admin endpoints.
Fantastic.
Okay,
so the door is wide open. How do they pivot that access to RCE? They need an endpoint that actually executes code.
And they found the perfect candidate. Applications Groovy script status?
sounds promising.
It seemed like the logical choice.
Right.
It's explicitly designed to take Groovy code, but when they sent a simple payload, something like system.getProperty user.name, they hit a wall.
What happened?
The response came back, 200, okay, script compilation successful.
But no callback.
No callback, nothing. The script compiled perfectly, but it was never actually instantiated or executed.
So that endpoint was just for syntax checking, a validator.
Exactly. And this is the point where a lot of attackers would just give up on that endpoint. But this is where the real moment of brilliance comes in, connecting this seemingly benign feature to a super advanced exploitation technique.
This sounds like it connects to that secured Java challenge from real-world CTF a few years back.
That's the one. The whole insight hinges on the difference between compile time and runtime on the JVM, and specifically how you can abuse the Java annotation processor.
Okay, break that down for us.
Think of it like this. Runtime execution is when the finished program is, running on the assembly line. Compile time execution with annotations is like running code while the program is still being built on the factory floor.
So if the final compiled code is just thrown away, you shift your goal. You're not trying to run code at runtime. You're trying to force execution during the compilation process itself.
That is the key mental shift. And Groovy lets you do this. They used a specific annotation, groovy.transform.ASIC test.
The abstract syntax tree test.
They define their malicious logic inside this annotation, and, this is the critical part, they set its phase parameter to compile phase semantic analysis. This forces the payload to run when Groovy is just analyzing the code structure way before compilation is finished.
So they weren't trying to run a command in a main method that would never get called. They embedded the command, like an HTTP callback to their server, inside the annotation itself.
Exactly. It's an amazing evasion technique. The payload doesn't need to produce a working program. It just needs to trigger that system call while the compiler is active. The second they submitted that payload through the matrix parameter bypass, they got the callback.
RCE.
SB achieved, using a feature that was only ever meant for static code analysis.
What's really so illuminating here is the contrast. You have these two halves of the exploit chain. It starts with a ridiculously simple, almost embarrassing legacy flaw.
A few characters in a URL.
And it ends with bleeding-edge expertise in JVM internals and compiler phases. That fusion is what makes it so dangerous and so easily weaponized.
It's the perfect storm. You have a wide-open front door, protected by some brittle string matching, that leads directly to a high-privilege engine that you can trick into executing code.
All right, let's pull back and talk about actionable intelligence for everyone listening. First, it seems like the biggest risk here is still that old-school, centralized filter logic.
Without a doubt. If your org has legacy apps that are still using custom filters to whitelist paths with basic string or regex matching, you are exposed, period.
Because they just can't keep up with how modern frameworks actually parse and canonicalize paths.
Right, they're trying to outsmart the framework's routing logic, and then they will always lose.
And second, the matrix parameter trick. This is not a new bug, but it just keeps working. It demands attention.
Any system that relies on strict path matching for security, especially in a Java environment, needs to be audited for these kinds of canonicalization flaws now.
And finally, that RCE technique, it just highlights how valuable it is to stay current with advanced research, even from things like CTF challenges.
It really does. An adversarial mindset is what turns a feature that seems totally benign, like a syntax checker, into a critical vulnerability. That's a gold standard of proactive security analysis.
And being proactive is key here. The researchers gave organizations 83 days of preemptive protection before this went public. That kind of lead time is huge. It moves security from just reactive patching to genuine risk mitigation.
And if you just step back and look at the architecture, you have to ask a fundamental question. Why does this vulnerability chain even exist? It's because developers chose to rely on complex manual string processing inside a security filter, instead of just letting the framework handle route-level authorization properly.
They built a house of cards.
They built an exploitable whitelist, just waiting for the next trick, like matrix parameters, to come along and knock it all down.
Which raises a really chilling final thought. Given the complexity of a code base like Oracle's, how many other legacy systems in your own environment are running similar, brittle filter logic from years ago, just waiting for the next path manipulation trick to blow the front door wide open?
That's the question every CISO and security team needs to be asking themselves right now.
A compelling and slightly terrifying note to end on. Thank you for joining us for this deep dive into CVE 2025-61757.
Stay sharp and keep digging into those old legacy filters.